Hello everyone, I am Jagdish Patel, Assistant Professor, Sandhi Foundation, Nasik. The name of subject is Broadband Communication System. This is Unit 2, Light Wave System. Today we are going to see in lecture number 1, Optical Sources in Fibers. I am having 12 years of teaching experience, specializing in digital communication. History behind optical fibers communication. Introduced in 1970, fiber installed for telephony in 1980 early, long distance land-based fiber installation completed in 1988. Submarines optical fiber cables installation began in 1988. LAN application uses optical fiber in 1988 million, that is 10 kilometers of optical fiber by 1994 worldwide. Point to point to distributed network, optical to home, optical to fiber, sources and detector, componentized connectors, spices, advances as the optical amplifier, circulator, attenuator, filters, wavelength division, multiplexing, external modulators. So this one is nothing but the spectrum utilized for transmitting the signal over optical fiber. Electro-optic semiconductor device. Sources are LED, and detectors are ADP pin. Here, this one is integrated optics, coherent technologies, uses 10 to 20 dB of improvement. WDM multi-channel optical system, FO components, connectors, couplers, optical multiplexers, splices, etc. Other optical fiber developments, that is sensors and instrumentation, photonic switching, optical computing, and signal processing, optical amplifiers, tunable lasers, and solutions. This one is a tree, optical fiber system, having different number of branches and applications. The applications of optical fibers are: they are used in science and technology, chemical, physical and materials, optics, electromagnetism, glasses. They are used in biomedical applications, sensors, computer applications, ISDN, video, gaming. After that, long haul communication, submarines, optical fiber cable, short haul intra cables, subscriber, loops, antenna, and so on. So here, these are the different parameters which are used for communications, which uses optical fiber for their data transmission. Consideration with optical sources. Physical dimensions to suit the fiber, narrow, radiation pattern, beam width, linearity, output light power proportional to driven or to driving current, ability to be directed modulated by varying driving current, fast response time, adequate output power into the fiber, narrow spectrum width or line width, stability and efficiency, driving circuit issues, reliability and cost, and so on. Semiconductor diode requirement, that is longer wavelength, reduced operating current, better mode stability, and longer life. Semiconductor light sources. A PN junction that consists of direct band gap semiconducting material act as an active or recombination region. When the PN junction is forward biased, the electrons and holes recombines either radially or non-radially. This is simple LED operation. In a laser, the photons is further processed in a resonance cavity to achieve a coherent, highly directional optical beam with narrow line width. Injection laser, photons emitted with electrons fall from CB to VB. Stimulated emission, much brighter, 10 milliwatt, faster response, narrow line width, life 1000 to 2000 Hz, 10,000 to 20,000 hours, non-linear characteristics, bandwidth that is several megahertz at full power. LEDs. Light emitting diodes. Photons emitted with electrons fall from CV to VB. Spontaneous emission less brighter, that is output 0.1 milliwatt to 2 milliwatt. Slower response, wider spectral width, life 10 raised to 7 hours. Linear characteristics, that is bandwidth 50 megahertz. This one is free space optical link. Input signal is given to the modulator, optical transmitter. After that, signal is given to the optics. After that, it is given to the beam. Receiver optics. From receiver optic, it is given to the optical receiver. And after that, it is given to demodulator and the signal output. In this way, the signal is traveling from input to the output with the help of optical links. Detector, silicon photodiode. Requirement, small size, compatible with optical fiber and sources, good sensitivity, reboost devices, fast response time, and longer life. Avalanche photodiode, ADP, APD. Lower optical power required, gain control possible, high bandwidth, limited linearity, multiplication noise, 100 to 400 volt bias critical. Pin diode, larger optical power requirement, easy of use, lower bandwidth, that is less than 50 megahertz, high linearity, no multiplication noise, 5 to 80 volt bias. Sources of noise, thermal noise, short noise, excess noise in multiplication, source noise, model noise due to misalignment. Conceptual development of optical networking, achieved and to be achieved. Point to point, that is multi-wavelength transmission, improved further with EDFA coming, capacity increases on existing system, broadcast and select network, that is concurrency, start network, simple, broadcast star switching fibers, switching in wavelength, domain avoid complexity of time and space switching. Wavelength routing, selective routing of optical signals according to their wavelength as they travel through the network, wavelength reuse, WDM cross connect, rearrangeability through space switching, wavelength selective elements, add drop capability, wavelength reuse in multi-hop network, wavelength conversion, change wavelength translation, change wavelength beyond boundaries of administrative domain, large scale network, transparency, data format, etc. Network layering, optical connectivity layer, fiber sonnet ATM, now fiber optic connection, transport switching, network management control and operations in transparent system, monitoring and control. So these were the history behind optical network. We have also seen the different diodes, different components which are used for transmission of optical signal and their parameters. Thank you.